It is from gate 2025. The question is, the diode in the circuit shown below is ideal. So this is the diode. The input voltage is given by Vi equal to 10 sin 100 pi t, where t is in second. Okay, so given Vi is a sinusoidal signal, right? And the peak is 10 and minus 10. Right. So what is the frequency here from the signal? Vi is equal to 10 sin 100 pi t. Okay, so this is like 2 pi f t. So here from the equation, what is f? F is equal to 2 into 50 is 100, right? So f is equal to 50 hertz. Right. So what is the time period? So if this is the total time period of this input signal, time period I will call t as equal to 1 by f, right? So that is 1 by 50, that is equal to 20 millisecond, right? So that is the time period. Now the question is like the time duration for which the diode is followed by. So if you see here, it's actually a clipper circuit and it's a bias clipper. Here it is minus and plus, right? So when Vi is 0, this diode is actually on. Okay, so it is when Vi equal to 0, diode is on. Okay, and if you see, since it is already on, for Vi greater than 0, diode is on. Right, so during this case, when Vi is positive, the diode is on. When does diode becomes off? So when diode becomes off, when this voltage minus this voltage is 0 or less than 0, right? So when Vi minus 5 is less than 0, right? Or Vi is less than minus 5 volt, okay, diode is off. Right, so when does this happens? So when does Vi becomes minus 5? This happens when sin 100 pi t is equal to 1 by 2, right? So when does this happen? This happens when the angle, right, 100 pi t is equal to, so there's two cases. Okay, when this it becomes minus 5, this is when at this point and this point, I will say this is t1 and I'll call this time period as t2. Angle, what is this? This happens when t equal to t1, that is 100 pi t1, and this happens when this is equal to pi plus pi by 6. This is one case, that is like can happen at 180 plus 30 degree or 360 minus 30 degree. These are the two cases when this becomes 1 minus 1 by 2. So that is pi plus, in radians it is like plus pi plus pi by 6. Pi by 6 is 30 degree, right? So from here, if we calculate, t1 will be equal to 7 by 6 into 100. 7 by 6 into 100. Okay, and so this will be t1. And the case 2 is like when t is equal to t2. So this happens when 100 by t2 is equal to this case, that is 2 pi minus pi by 6. This is the other case. Okay, so here t2 will be equal to, if you t2 is equal to 11 by 6 into 100, right? So here, if you carefully see, from t1 to t2, the diode is off. And the remaining time, that is this time, diode is on, and during this time is also diode is on. So on time of diode is like total time t minus t1, the total the time when diode was off, right? T2 minus t1. Okay, so if I substitute, t is actually 20 milli minus t2 is 11 by 6 into 100 minus t1 is 7 by 6 into 100. So if you calculate this, you'll get near to 13.3 millisecond. So the answer is 13.3 milli.